Hello, everyone.
Hello.
Hello.
If my keyboard is being too much, just let me know.
All right. Welcome. We'll give it another couple minutes just to let people join. I put the meeting notes link in the chat. I'll probably need to do that a couple more times. Please add yourself to the list of attendees, any updates that you might have, and add any agenda items that you would like to discuss. We do have a presentation today.
Hi, Brand. So we actually wanted to check how long the presentation is for. Is it 5 minutes or 15 minutes?
For presentations, we have this meeting set up for an hour, 60 minutes total. I would say that we've done community demos that are usually between 5 and 15, but presentations we've allowed to run longer. So take, 30, 45 minutes, like as much as you need.
Awesome. Because we saw in a doc that it's 5 minutes, and both of us got a bit scared that now we need to cut everything and keep running the demo towards the end. Yeah. Okay, thanks.
Absolutely.
Hi, everybody.
Where is... All right, just to get this out of the way. Hey, everyone, just a reminder, this meeting is being recorded and it's posted to LFX shortly after. Your participation in these meetings is an agreement to abide by the Cloud Native Security Code of Conduct, which can be found both in our repository and elsewhere that we can link you to. If anybody's willing to volunteer as scribes, that would be wonderful so we can help document discussion. And for anybody who's existing member, working group, initiative, subproject related to the tag, if you have updates, please let us know so we can set aside some time to discuss those. Just for posterity, yep, looks like Mike, you posted meeting notes for people still joining. Thank you.
I think I can scribe if needed.
Ooh, thank you. And then just validating, we do not have a... Technically, we have this in the community demo spot, but I think this is the OR presentation. So we don't have anything else that we needed to cover before we kick that off. I guess I will send out one request for anybody who is new to these meetings. Everyone outside of our presenters looks familiar. So I don't think we have any new members, but if you have anything to bring up before we kick off, I'll pause for a moment. Wonderful. With that said, then we can jump into our presentation. I will hand it over to you all to explain to us more about the bloat-aware file system.
Sure, thank you, Brandon. I'm Huaifeng, and today I'm going to give the presentation about BLAPS, which is the bloat-aware file system we developed. So let me share my screen for the slides. Okay. And do you see my screen?
Yes.
Okay, cool. So yeah, so today's presentation is about BLAPS, which is basically a container debloating tool. And to begin with, so we first describe what is container bloat. So container bloat basically refers to the files that are unnecessary for the target application. Basically, we use container to run certain application, but apart from the application itself, we also package many unnecessary files actually. So such bloat, it consumes unnecessary storage space. It also reduces the performance with significant code start delays in serverless environments, for example. And also, another major problem is that these unnecessary files, unnecessary code and dependencies, they increase the attack surface. Actually, there's a talk recently that is talk about this issue, which is why bloat is still software's biggest vulnerability. And also, we recently showed that containers can be very large. For example, for some machine learning containers, can often exceed like 2 gigabytes and sometimes over 30 gigabytes. This is the statistic from the DocHub, which lists the popular downloaded containers. And also, we found that reducing container bloat also significantly decreases the number of CVEs. This is a result from our research that we show that we examine some containers and we remove the bloat, and we found that by removing bloat, that the number of CVEs decreased significantly from like 74% to up to 99%. And container debloating, actually, there are some existing tools. For example, the first one is Simplifier, which is from academia. Which is also open sourced, and also another one is Slim Toolkit. I think it is already a CNCF sandbox project, if I'm correct. And we evaluated the effectiveness of these two approaches on top 20 downloaded containers from DocHub, and we found actually their effectiveness is not that good. So we found like out of the 20 most downloaded containers, we found like Simplifier only successfully debloat 7 containers, and Slim Toolkit debloats 8 containers. And so we analyzed like why Simplifier and Slim Toolkit fail. So as we have shown before, so they are not effective in debloated containers. Their success rate is less than 50%. The reason is that they use the tracing techniques to trace the file use. Like in Linux, they use stress to check the file access system calls and extract the file access. But these tracing techniques, it's not extensive. It may fail to capture certain file accesses. And also, both debloaters, they only begin tracing after the container has started running and cannot. This is some type of cannot capture files accessed during the startup phase, because we found that for some machine learning containers, during the startup phase, it actually accesses a lot of library files. And also, both debloaters, they break the layer structure of the container file system. So thereby, they they reduce the the advantage of layer sharing of containers. The total size of the debloated containers can be even larger than the original ones. It means you remove bloat, but because the resulted container, they cannot share the layers, and the total size of the debloated layers can be even larger. And so rethinking the cost of the container bloat. So a container has a layered file system, which basically nowadays it's the overlay file system. And this layered file system architecture is also a major cause of bloat, because most of the containers are built on top of a base container image, where a container inherits all the file system layers of the base container image. So any bloat in the base image is also inherited in the new container, with the new bloat possibly added with each layer added to the file system. So since it's the reason, so file system contributed to bloat. So Blepps reduces it at the file system level. And so the layer structure contributes to bloat. So Blepps leverage the same structure to debloat. And by removing unnecessary files, also removes many vulnerabilities, strengthening the container security, as we have shown before in previous slides. So how do we do that? How does Blepps do that? Yeah.
There is a question, Ivan. I think there is a question.
Yeah, go ahead.
I think I figured it out, but you talked about the success rate of debloating in an earlier slide. And,
yeah, this one, right?
I was wondering what the success rate here meant. Like, what was the definition?
Yeah, let me for example, the most basic case, you wanted to debloat the Redis, and both simplifier and slim toolkit, and also Blepps, it works in the same way. So you start the Redis container, and you perform some workloads. It will identify the files required by this whole process, and then it will generate a container that only contains these files. Basically, you can use the debloated container to run the same workloads. That's if you can't do that successfully, it's a successful debloating. But
so if the container runs the same workload again successfully, then you treat that as successful, and then you measure the size reduction on the ones where the container was able to start successfully.
Yes.
Okay, thank you.
So it's clear that here the successful rate is, it means basically the resulted container, it cannot run the same workloads. Okay, let's back to the slide. Yeah, here. So how does Blepps work? So basically, we implement a file system, a user space file system. So Blepps introduce a new layer. So we call it a debloating layer to the original container file system. So a debloating layer D, it hides a list of image layers as its child layers. And when reading, not only reading, I mean, when accessing a file from a debloating layer, so the files is moved from the child layers to the debloating layer. So here is an example of how the debloating layer works. For example, this is a container. It has two. Its original file system has two layers. We use the gray box to represent the original image layers. And then we convert this original file system to Blepps file system by adding one debloating layer, which is represented by this blue box. And this debloating layer, it hides the two original layers as its what do we call it, the child layer. And when you run the container using the Blepps file system, and when the container, it reads some files, for example, in this example, it reads F1 and F3. F1 and F3 is moved from the original layers to the debloating layer. So basically, this simple mechanism, it separates the files used and the files not used. And to debloat, you remove the files in the original layers and only retain the files in the debuting layers. That one you get a container that only has the the required files. And in left, the debuting layer, it acts as a basic building blocks. That means you can add the debuting layer in different ways to meet your user case. Here is the most this is the easiest way to add a debuting layer. And yeah, so we based on this basic block, we have two modes of collapse. So the first one is no sharing mode, which guarantees the minimum possible size of a container for the profiling workloads, or by the target workloads, by removing files that are not used by the profiling workloads. Also, another one is layer sharing mode, allows for the sharing of common files across multiple debloated containers located on the same host. For the non-sharing mode, no sharing mode is that so give a container with like unimaged layers. So the no sharing left inserts one debloating layer, which has all the original image layers as its child layer. For example, here, if we have for two containers, and we insert one debloating layer for each container, and then this will result in two separated containers with no files, no layers shared. And in this example, so after debloating, we have two containers, and their size is reduced from 10 to 3 megabytes, and another one is reduced from 10 to 5 megabytes. But the total size, it's like, you just simply add them together, it's 8 megabytes. This is no sharing mode, but the individual container, it has the most the smallest size. Another one is the fully sharing mode. In this mode, so given a container with n image layers, so we insert n debloating layers, each of which has one image layers of its child layer. So when you reuse the previous example, here we have the two containers, and we insert a debloating layer per image layer, and in this in this specific case, it will result. The two containers actually they have the same file system. The individual size are reduced from 10 megabytes to 6 megabytes, both of these two containers. And their total size is actually also 6 megabytes. As you can see, if we compare it with the previous slides, the individual size is smaller, but the total size is larger. In this case, the individual size is larger, but the total size is smaller. So that's why we have two modes. But it's not limited to these two modes. You can insert the layer, the debloating layer, according to your own user case. For example, you only wanted to debloat certain layers of the container, or you only wanted to debloat maybe only one layers of the container. It both works. You can just insert the debloating layer according to the need. And also, this is also the problem I think mentioned by some developers. So they want to know how to integrate with Kubernetes. We have been working on this, and so we have two ways to do this. So the first one is that you can basically we can start a Kubernetes cluster with Collapse installed. And then we create a deploy. For example, we create a deployment with image. In this case, we still use Redis as an example. And then, I think we can, use some kubectl plugin to, to add a new command to the kubectl to convert the container file system to Collapse. And then, basically, you run a container as the you run a container with the workloads you want, and then you can run the deployment for a period of time, for example. Then deploy the containers using another custom command to do this. And actually, so we have a demo in the GitHub repo, which is a pull request and haven't been merged to the main repo. And also, this is special thanks to Thomas, which built the demo for integration with Kubernetes. This is one direction. Another direction, I think, I mean, current version of Labs, we focus on providing a command line tool. But I believe an alternative way to do this, to integrate it with Kubernetes, is I think we could re-implement it as a continuous snap shorter, which might be another way to integrate with Kubernetes. And yeah, here are some, I mean, empirical results we have. So we evaluate on the top 20 containers from Docker Hub, and we Bluff successfully deployed all the 20 containers, and also, I mean, the size reduction is also quite significant. And also we also do some evaluation on the vulnerability reduction. It also shows a significant number of vulnerability reduction, which is also in line with the previous results we have shown before. Also, we believe that Bluff can be also combined with some existing lazy loading stamp shorters to further enhance the provision performance. And debloating, I think Bluffs can improve two key metrics of lazy loading stamp shorters. The first one is that image format conversion. Sometimes, mostly we need to convert to the image format in order to use some lazy loading stamp shorters. And also, container put time is also reduced according to our experiments. But we don't show this in these slides. And finally, we have a demo for this. And before starting the demo, I just wanted to check if there are any questions.
I guess, like, I have one, but this might be a little bit of a distraction.
Yeah, no problem.
So I totally buy debloating as an efficiency gain, but I don't know that I fully buy it as a security improvement. And I'd like to be better convinced. And Evan, if you're stepping in to say, like, this is out of line or I shouldn't say it, go ahead. Otherwise, I'll.
Oh, no. I was going to chime in that it depends to some degree on how important you think detected CVEs on disk are in terms of actual application vulnerabilities.
Okay, so yeah, let me give you a hypothetical example here. Let's say that I go and I'm going to ship a piece of code, and along with that piece of code, in a documentation file, I include a whole bunch of vulnerable, like, because I'm talking about like why security is important. I happen to just include bits of vulnerable code in my documentation written there. Just source code that this is an example of, you know, use after free. This is an example of whatever, right? Now I am technically shipping vulnerabilities in my code. Now they're of course not executable and they don't hurt anything. I think we'd all agree that situation is completely benign, right? It just doesn't matter if I do this.
But so, I mean, it's a risk, right? It's a risk. You kind of ship a mine in your container.
No. So if I go in a documentation file, in the actual documentation for my software, I say, by the way, here's an example of what a buffer overflow looks like in C code. And I just write like a snippet of code that is a buffer overflow that's in my PDF file that is the documentation. It's not executable, right? This is not a mine. This is a mine that you basically cannot trip over in any way, shape, or form. So this is one extreme example.
Yeah, okay. But I can also give you one extreme example why this can be. I mean, another example that why debloating can. Why bloat can be a security concern. For example, if you check the Docker container, actually there's a lot of like, malicious container images. They use, they use a similar name like TensorFlow. They maybe have some TensorFlow plus with S, which is very similar to the official TensorFlow container. But you accidentally download that container, which they package some, maybe some like malicious executables, and you use that container. and you use that
that's
container.
typo squatting. That isn't debloating, right?
But if you can't do, I mean, if you can debloat it, basically means you can remove the malicious payload they packaged in the container, right?
So if code is not reachable, if there's no possible way in your execution to reach a piece of code without an exploit that would completely compromise your system, is it important to remove that exploit?
But what if it's something that is a backdoor? Maybe it's a backdoor.
If it's a backdoor, it's reachable, then it matters.
Yeah, it's a backdoor. Like it's a backdoor, but when you use it, it's not activated. It's not activated. It's only activated by the attackers.
Right. So I guess what I'm saying is that part of the point I'm trying to make here is that a lot of the debloating work that I've seen, and I don't know enough about yours, but a lot of what I've seen, especially out of academic efforts, focuses on removing code that is completely unreachable. There is no code path. There's no possible way to reach that. And that's actually very common. It's actually very common to even have packages that are not reachable, that get installed because something had a dependency on it, and the part of the package that had the dependency doesn't even use, that isn't even used in the original application.
Yes.
So those from an efficiency standpoint make sense, but I don't, and from a compliance standpoint of getting people off of your back from a scanning tool telling you have a vulnerability, it also makes sense. But I don't buy in necessarily to the argument that that's a security improvement, because if the code isn't reachable, the only way to reach it is to have some other exploit that lets you escape the normal code flow and break memory safety. Then at that point,
I got a point. Yes, I got a point. Yes, I got a point. I mean, yes, this is one case. I mean, we can also have some other, I described it before. We can have some backdoor connection attacks that that is different from your workloads. But that kind of attack, it exists in the container. So why I would say it's a kind of a risk to to keep it in the container instead of remove it. Yeah. But I totally get your point. Yes, I also agree with that with your points. So I also say someone raise the hand. But
Michael, thank you.
No,
I think Michael.
Oh, okay. No, I just want to make a quick comment, and this I think is maybe even a really good topic for a future tag security and compliance meeting. I would and I want to let you also all get to the demo, but I would actually argue that if I only have $1 to spend on security, the less stuff I have to look at because it's not even there, and I don't have to see, is this reachable, is already an improvement. And I agree that some of it's just purely compliance, but a lot of it is just, hey, if I have a 10 gigabyte, VM with a bunch of different things, and sure, most of it is not accessible, but even just looking at it, running the scans takes time and money and all those sorts of things. If you were to say, hey, here is a much smaller set of things you need to look at, even in the first place, that's already a big benefit, especially for, I would say, in the private sector, right? I agree that in sort of academic circles, there's a lot of different, things, but when it comes to the private sector, it's hey, if I have 100 different things I need to look at versus 10,000 things or 1 million things I need to look at, it saves me time, helps me get to market faster, and all of that sort of stuff.
I can add very quickly that it's not only dollar. People pay a lot of money to chain guard, right? So for getting a chain guard, you pay neck and dime. So Deep, thank you. Sorry.
Yes, I have a question. So what I'm getting out of it, the accuracy of the removal of the files is directly governed by the workload testing you do, right? Is it an iterative process? Because the question I'll be asking is, you can do all workload, but if I take a very simple example, if you package VI, which is not being used by any workload, but apparently when you do, let's say, SSH to container and then you want to use the VI, then that wouldn't be caught unless you actually try to do that, right? So why would you not be also deploying tracing? I mean, why did you abandon tracing altogether? Like what Simplify does?
I mean, even
I can take one part of the question and then we can go to the other part. So one feature that we have been asked for, well, we sort of did a release and we talked to people on Reddit and so on. And one thing that people basically asked us for is the ability to for an operator or whoever is running this to basically say, okay, I want these. Like I want these. This is my safe list. I do not want you to remove them. I do not want you to remove, I don't know, Bash or whatever. I mean, whatever tools that you need, you just basically tell me that these are the tools that you're going to need, and we're not touching them. So this is the feature that we're going to add. But then I'll let Weifeng reply to the second part of it.
Yeah, I mean this kind of thing is also no matter using like tracing or the file system like Blobs, it all have this problem. Like I mean, you have VI, but you don't use it. Maybe you need it in future. But if during the working profiling you don't the VI is not accessed, it will be removed by Simplifier, by Slim Toolkit, and by Blobs. It's I mean, no matter it's using tracing or file system, yeah. But I mean, this is a problem.
No, I think I understand the VI part. I think I was just trying to get that confirmation. But I would still say that if you don't do tracing, it all ties to how much, I mean, how complex testing you have done with your workload. Otherwise, you will miss something.
But even if you use tracing, you still need to run complex workloads to cover. I mean, to improve the coverage, right? It's actually it's the same.
I mean,
yeah, I think I got it.
Or you can do static analysis, which will
yes, we have that part. Yeah. We have that part, but not in open source work. We have been working on that. Yes, that's good.
Yeah, I think I think I got it. Yeah, thanks.
Okay. So if there's no more question, let's show a small demo quickly. Okay. Let me reshare my screen. Okay. Could you see my screen? Okay, cool. So now we have a clean Docker environment. We have no images. And what we are going to do now, we are going to deploy a Redis image. And firstly, let's pull the Redis image. Okay, we pulled the Redis image. We can see it's more than 100 megabytes. And how do we deploy it? So we use Blobs. The first step using Blobs. Here we call it Blobs, but it's just a naming thing. So first we use Blobs and we run the shadow command and we specify the image name. In doing so, we will convert the underlying image to Blobs by inserting a deploying layer, which we have discussed in the slides. And after that, I mean, after that you can run a container as a normal container. Basically, the file system is transparent to users. You just use the container. I mean, as the original container. In this case, I mean, we just for the demo we just run the Redis container, just start it. So we can say it started successfully, and then we stop it. So this is a demo profiling workloads to deploy to such a Redis container. And after that, the next step, which is also the last step to deploy the container, is that we use Blobs and the deploy command. We specify the image name. This will, remove the files that are not used by the startup process. Here, we will have another images. As you can see, this one is the original image, which is more than 100 megabits. And after debloating, we get this image, which is only, less than 30 megabits. Let's verify the debloated container. It still works correctly, which means we can still start the Redis using the debloated one. So let's reuse the command here. Basically, as you can see, it starts as a normal container, and we can correct it. We can shut down it. Yeah. So yeah, this is the demo. Basically, the first step, you use blobs to convert the original container image. Then you run the container as the original image. You can use it to serve the Redis server, to serve the request or anything you want. After all the workloads, you use the blobs to debloat it. It will generate a smaller container, which only contains the necessary files. Yes, that's all for the demo.
We weren't sure how long we had, so we made it as short as we can.
Yeah, yes, maybe it's a bit short.
But we have tried it basically with even generalizability. So if we run it, if we debloat with a certain workload, and then try a different workload, does it work? And when does it fail? And we have some features such as so the no sharing mode that Weifeng talked about is we think of it more as a security hardened mode, where you know that this is the workload. So it's maybe a microservice that you have been running, and you know this is the workload. So your final phase, you're just going to deploy it at scale, and you're not going to touch it, or you minimally going to touch it. Let me put it that way. So then you are not expecting anyone to mess with it. So that is that is our most secure mode. That is the no sharing mode. With the layer sharing mode, we actually have even the possibility of pulling any. So if we make a mistake when we debloat first, we can actually go and remote fetch the file that we removed that would be needed. But then it breaks the security in some sense, because then if there is if this is actually if we go back to the is this reachable code, and if it's reachable code because of a vulnerability, then then that can get pulled again. Yes. So there is another question in the chat, I think, which is, this only works if I run the image by tag, not by content digest, right?
For now, yes. For now, yes.
Yeah. So, yeah.
Well, it looks like you generate a new image tag name and a new image digest. So you could do it with image digests as well. It wasn't clear to me where you were hooking in when I asked the question.
Okay. Okay.
Bram, I think you have it.
Yeah, I think less of a question and more of just a observation of I think that your rebuttals to certain arguments are valid. When I go to the repository, I see the how. I don't see a lot of why, and I think that there would be a lot of benefit to the community of understanding why do you perform this, and also just the general FAQ of here are themes that are emerging of feedback that we get about whether something constitutes something being more secure or as efficient, or is there a loss of capability? Where do the edge cases fall? And I'm really interested to hear, kind of see how that evolves over time.
Mm-hmm.
Thanks. We have actually applied for incubation for sandboxing, so hopefully we will get through also. So we would like to continue working on this for some time. Yeah, Josan.
Yeah. So given that you're sort of modifying the software that's running, do you generate like in toto attestations or SBOMs or things like that to describe how this modification is taking place?
For now, for current version, no, but I think this is a good suggestion. I think it's best to generate some like SBOM to list the files accessed. Maybe it's yeah, I think it's a good suggestion.
I think if it's compliance you really care about, then SBOMs are the right thing. And if it's security you care about, then attestations are what you should be doing. And I also think there's no reason why you can't just generate both, because
it's doable. Yes, it's totally doable.
So, okay.
Yeah, thank you.
Yeah, I think to my comment in the chat, I fall down a similar vein, but from like the developer perspective of how do I know what was considered bloat and as a result was removed, and is that auditable in such a way that I can, me as maybe like the subject matter expert on Redis, can actually review that and be like, no, maybe like this piece is actually critical and I don't want it to be ignored or removed.
Yes, it's kind of yes, I agree. Kind of we need to generate some like it's a kind of similar to the diff files like.
Absolutely, yeah, that'd be a great take.
Yeah.
Okay, I think that's us. Thank you. This was very good for us.
Yes, we appreciate the time. Thank you for coming.
Thank you for attending.
Thank you. I guess I'll drop out.
Yeah.
Sounds wonderful. Thank you all.
Bye-bye.
So yeah, from here, hit the rest of the meeting agenda. I don't see a lot sitting in there currently, but I will at least share my screen and walk through, make sure there's nothing that we are missing. All right. So we have presentation, other meeting. I don't see a meeting on here for another time zone. TOC meeting updates. Do we have any updates?
There wasn't a public meeting yesterday, but I think there has been. I guess I have a question more than an update around for the group around the TOC repo stuff. I know Evan's here. I don't know if you want to chat briefly about repo updates. That might be a nice update to have here. We're working on it. That's why I call you out.
Yeah. Yes. Sorry, I had to step away for just a moment. Do you mean in the context of initiatives and so forth, or just in general?
I mean, anything you think would be helpful for other folks who are trying to use it.
So it appears that the TOC is attempting to move towards more of a monorepo situation for the TOC's work and all of the subgroups that it manages. So this is, the desire is there and the tooling is making its way there. And so their current guidance is that initiatives and subprojects and tags should all be getting subdirectories in CNCF TOC, using issues and projects in CNCF TOC, and they will use code owners to give people access to sub paths. And the code owners change merged either end of last week or on Monday. So that is new. They also have some automation for filling out the READMEs and for the tags and the subprojects, which was broken. in that it was attempting to overwrite our charter, among other things. So I did a PR to fix that. After trying to do a PR to correctly fix Brandt's name and John's affiliation, and discovering that it tried to delete our charter. Yeah, not everything is working, but there is an aspiration to move towards a monorepo style thing where all the code and documents and so forth from all the different efforts is in one Git repo. And I see Matt has his hand up because he's partially impacted by this.
Yeah, across multiple tags, it would seem. One question I had from being a GitHub Enterprise owner for an organization before and managing stuff like this is the code owners mechanism gives a lot of flexibility for partitioning off subtrees to be managed effectively. But I'm not sure if the same is true for issues. So for example, if we make projects in the TOC repo and I put my 20 tasks, in a task breakdown and make a roadmap, are they delegating control of like manipulating issues? What tags can
I believe that there will be some bots to be able to assist you with that. Go back to the earlier statement about there is a desire and an aspiration, but not all the mechanics are in place yet.
So then we should make org level projects is the takeaway, right? So that in the future, if we need to use additional repos or other things, we can, or even referencing prior art from other repos, org level projects let us do that while repo level projects don't.
Yes. When I was using repo level projects in Knative, I forget what the other problem was, but the access control on org level projects was more granular, if I recall correctly. There was something where it worked.
So we need clarification there better. from TOC.
For projects, I think we may want to ask.
Yep. I can
currently they are using repo level projects.
Okay. All right.
And now I'm remembering what it was, which was that you needed to have write on the repo in order to be able to manage any of the repo level projects, whereas you only need to be an org member to be able to manage org level projects.
Okay, so then we should probably do repo level projects, particularly if we're going to use workflows or other things. Is that the takeaway? Or okay, well, I'll chase it down with them.
Well,
the other thing of two is
include me in the conversation if you could.
Oh yeah, absolutely. Yeah, no,
because I've gone down this at least once or twice before in other contexts. So there's trade-offs. It's not all happy shininess, and in some cases you're limited by what GitHub is able to do.
Okay. Yeah, the other thing that we'll need to do is get whoever is going to be contributing to these initiatives added as CNCF organization members. I'm one now,
or
but like you
writers
assign
on
an
the
issue,
TOC
for example,
repo. Yes,
without them being in either the TOC as a member and a contributor or otherwise. So I'll schedule some time with Jiffy and/or Bobby and you and whomever else makes sense.
Bob is taking a week of vacation tomorrow.
Okay, maybe Rian or something.
Rian is also on vacation.
Oh, lovely. Okay, well, we'll just make progress in the meantime.
It's the summer. We'll make progress as we can.
Sure. Okay. The last thing I'll say on this whole thing is, and I posted in Slack about it, the link is in the chat. I really do like the separation of, the CNCF asked us to make a plan and a new initiative, and a plan for an initiative is a new thing. I like having sort of like a process by which a plan, or at least a provisional plan, based on what's known at the outset, is checked in to something that's not under tag control, but that is merged by the TOC as my draft PR does, kind of following like the OTEP or KEP process, right? Where there's an explicit, like, these are the deliverables, this is the scope. And if that changes, a PR process can address it, but it forces the TOC or at least the liaison to kind of have an active role in approving those things. And it gives us a lever to have something to talk about that's actionable. So whereas then the actual project artifacts and sub, the granular details we manage, but the overall plan or the contract about what this is, and that understanding is there. So
I'm not sure how much of that needs to be enforced via hard technical means versus social means.
Fair. Yeah.
I know a bunch of us like to write code and use hard technical means to solve these things, but
well, for me, it's more about like if somebody discovers this initiative a year later,
yeah,
in 2026 and wants to like bring it further. That's why I've been updating the GitHub issue, because I want to make sure that at the end of the day, the history of GitHub contains the history.
I agree with that. And if the content includes a mix of the purpose of the initiative is X and the initiative meeting notes are at location Y.
Yeah, that's probably sufficient. And I don't imagine everyone else is going to write plans.
We probably don't need to bug the TOC to update.
Yeah, that would be even more things for them to merge. So
yes.
So do you want me to move the plan in my draft PR, which is still draft on purpose?
I put a comment in it. Yes.
I'd like you did. Okay.
Under the tag.
Oh, then we're playing Slack tag, and I'll stop talking. Thanks.
Yes. But yes, so the general summary is that we should expect to move our content under CNCF TOC, including for sub-projects and initiatives. At least until Win changes a different direction. Which is always the case. It's hard to foresee the future.
Under CNCF TOC tags, tag security and compliance / whatever.
Yes.
Okay, I'll get with you offline then to make sure we get a good directory structure that is.
But also that's actually the security reviews are doing something slightly different as well, where the reviews end up going to the project under projects. So that's a different thing for Justin to sort.
I didn't raise my hand, but brief last question on this very topic. How much or little do we want to use Slack and some of its facilities around like project overviews and boards? And I'm inclined to use it as little as possible, but
I think it's great to include pointers to things elsewhere.
Yeah.
I wouldn't use it as a primary source.
Great. We're in alignment.
Are we moving to project updates?
Let's do it.
Because it sounded like we were trying to do so.
Yes, let's.
So I have an update on the Supply Chain Insights initiative that Matt has also been talking about. We have a separate meeting scheduled on Mondays. We had our first meeting, which I thought was productive. We narrowed down on an initial focus for the community initiative part of producing a setup directions for a kind cluster where you could ask 2 types of questions about the sets of open source software running in the cluster. One was, if this license changed, through a rug pull, which software would be affected? And if there were a CVE in this library, which software would be affected? Independent of that, CNCF staff needs to be able to answer these same questions and is standing up their own Guac instance for their own purposes. And since they are all paid to do that, they are going to go do that whether or not we have the initiative. And so, yes. And we created a new Slack channel. Thank you.
Awesome. Thanks for the updates. Do we have updates on any other groups from any other groups?
I don't know if assessment stuff counts as a group, but I was going to kind of mention something that just got mentioned, which is basically I find the new setup a little confusing, but I'm doing a good faith effort to try to use this. It seems like people submitting these are also finding it confusing because they're missing stuff that usually people who submitted issues for security assessments didn't miss in the past. So if someone with more time than I have wants to try to dig into what's happening, that's fine. If we want kind of a leaky process where people open an issue and then never hear about it, because I never hear about it, then I think that's what we have right now. Then do nothing.
Yeah, I think that's fair.
I think it would be interesting to actually figure out what we think the process is now, because I did see we had one joint assessment request in the TOC repo, but I was actually curious, where do self-assessments go now? So do they also go in the TOC repo? I haven't seen anyone submit a self-assessment there.
Everything should be the same place. The way it was structured before is in a directory, 2 markdown files would get added. And what's supposed to happen is when they come to request the joint assessment, they've already done the self-assessment. And because the document is probably going to change really drastically and is probably going to have a lot of people work on it, we ask them to put that initial assessment in a Google Doc and then just to convert it to Markdown later when they're ready to actually check it into the repo and it's stabilized. That's the usual process, if that makes sense.
So just to make sure I'm recording that correctly, the self-assessment is done in a Google Doc.
Initially,
not checked in.
It gets checked in as Markdown.
Okay.
But because it's effectively highly commented on and highly almost collaboratively edited through the process.
You're not going to have to convince me hard that collaborative editing in GitHub is not fun.
Yeah. So because of that, we start with a Google Doc and then they convert it to Markdown, and that seems to take people a few hours and they seem happy with it. So yeah, but having the self-assessment is a prerequisite for getting a joint assessment, because effectively the main part of what we do in a joint assessment is get their self-assessment to not be unclear or biased or, to be more comprehensive and so on. And then in the end, we produce really usually about a page, maybe 2 pages, that are like recommendations / other things. And then that gets checked in. So the joint assessments you'll see that are checked in are really short compared to the self-assessments, but the self-assessment, the transformation of the self-assessment from where it started to where it ends up is pretty dramatic most of the time.
And I think one flavor of like additional information that requires coalescing is like the project reviews subproject also uses like this self-assessment in one of the criteria among other security related criteria and other non-security related criteria across that whole review for the technical reviews. And so there's certainly a lot of like moving pieces and trying to coordinate that across each project happening. But that said, still doing our best in good faith and whatnot to try to work with the process and figure out what are these kinks in order to maybe provide some meaningful feedback. All right, we are nearly out of time. In the event that somebody is or has something they really want to talk about at the next session, I will say that we would take volunteers for the community demo for next week. If you have something, please toss it out. It could be here. It could be in our Slack channel. 5 to 15 minute short, sweet demo, something concise that you'd like to talk about. With that said, thank you all for your time, and we'll see you all next week.